పట్టడం లేదు. హలో, గుడ్ మార్నింగ్. హలో, ఓకే సార్.
Yes, good afternoon, one and all. I am Farhat Tabassum from CSC department, one of the coordinator of this program. As we all know, today is the fourth day of faculty development program on big data and cloud computing. We have been learning many useful and interesting topics in the past sessions. I warmly welcome our respected resource person and all the participants to today's session. It's my privilege to introduce Mr. T. Gokaramaya Garu, Associated Professor from G. Pullaya College of Engineering, Kurnool, with us today. Sir has completed his BTech in Computer Science of Engineering from G. Pulla Reddy Engineering College and MTech from Pondicherry Central University. Sir has published several researches, papers in reputed journals. His area of interest: pattern recognition, deep learning, and computer vision. Now I would like to invite T. Gokaramaya Sir Garu to address the gathering and share his insight. Let's welcome him with a big round of applause. Sir. Sir, I will.
Okay. Hello. Okay. So good afternoon, dear students. I am T. Gokaramaya. So I am working as associate professor in G. Pullai Engineering College by deputation. Currently, I am doing PhD. So today Sir, we start with cloud computing first. So first we will start with cloud computing. Yes. PDF. Yes. Sir. So more afternoon session we will start big data so that we can have lab session also. So we'll get break again. So for lunch break. So this session we will discuss cloud computing, basics related to cloud computing. If it is problem, you can open it. Next. So I thank you, Dr. Raghavendra, Guru Raghavendra sir, for giving good opportunity to present here. Today we are going to discuss this session. We are going to concentrate on cloud computing, and next afternoon session we will concentrate on big data as well as hands-on session. Okay. So, what do you mean cloud computing? Do you know why we require it? What is the reasons going for cloud computing? Can you give any real world example? So, for example, with your family, that is your father, your mother, and with your sisters or brothers, and you are planning for the trip to visit the Hyderabad or nearest place or longest place. So, what are the options you have? Assume that you don't have the car. So, one option is we have to go and buy the car. Okay, that is one option. What is the disadvantage with this option? We need to invest the huge amount. Okay, another option is we can have the rent the car, so we can pay the amount. Okay, then they will give the for how many days. If you are planning for 3 days, 3 days amount we will pay, and we will use the 3 days. After that we will return it. And another option is rent without driverless. I means self driving. Okay, there are multiple options are there. So in the first case, what will happen? We everything that is how much diesel will be available in the car or petrol, and what is the engine status, that is what is the tire statuses, how much quality tires are there, all these things taken care by the service provider. In the second case, we are going to drive, so that according to our needs we are going to customize the car. Okay, in third case, uh, we are taken care by everything. So here in the first option, that is paying huge amount and getting the car, is one case. Here investment is the problem, or there is a chances that we cannot utilize later. After 3 days we cannot utilize it later. So if you have a good startup idea, assume that you are going to start the booking the online tickets. So what are the problems you will face? First, you need a good server to deploy your application. That is your problem. So to deploy your application, that is online, every user has to access. He has to access. Some users will prefer to accessing from the mobile. Some users prefer to accessing from the computers. Okay. Some users accessing from their different devices available. Okay. Now, what will happen is you have to maintain the constant infrastructure, networking, bandwidth, server, deployment server. So, buying the costly deployment, all this hardware, and after that, after developing your application, you can deploy there. Still, after deploying the application, you need to maintain the proper infrastructure, that is UPS, uninterrupted power supply, labors. You have to recruit high quality employees for maintaining the server, and all these things you have to taken care by yourself. And assume that there are some problems will be there, hardware failures or some other things. All these things you have to taken care. Now if you are taken care all these things, what will happen? You will not focus much on your application, developing the online ticket booking for the shows. So you will slowly will focus on the hardware, but you will not focus on your business idea. So solution is, instead of purchasing all these things, we can go a service provider who will provide the cloud services. So there are multiple options are there. You can buy the only hardware. That is the one case. Or you can give the completely development of application to there, and you will focus on the only your service, that is booking the online tickets. That is another case. And third case is, you will recruit some employees and you develop your own application and you will deploy it. So three scenarios will be there. Okay. Now why it is called as a cloud? Why it is called as a cloud? Can you guess? What is a cloud? Why it is called as cloud? So assume that instead of cloud computing, here it is network. Okay, we have the network. Then we have the server here. Okay, now we have the mobile user and some laptop user, some other resources. Now, if we draw a network here, how we will draw it? Generally, we will draw some look like network. If you want to connect the two systems between, and we will write a network, and we will draw a diagram which look like the cloud. So they derived from the cloud. Most important one is we can access the services from different devices. So it will not restricted to one desktop or like that. So the main parts of the cloud computing is, we have first resources. What are the resources? Computing resources and storage resources and network and services and applications. And next part is infrastructure. Now how we are going to deliver the methods? How do you deliver the things? And deployment. So whether it is a public cloud or whether it is a private cloud. Next is definition of attributes. So how do you utility computing, that is on paying you are going to use it, how much pay you are going to use it. And most important simple example, that is power supply to our home. Okay, based on how much you are consuming, that much amount we are paying. Okay, we are not bothered about the whether the current is produced from the coal, or whether the current is produced from the solar, or whether is current from produced from thermal energy. So we don't bother it. Okay, the power we will utilize it, and how much you are having utilization, that much amount we are going to pay it. So in order to handle all these things, we will prefer the cloud computing. So the evolution of the cloud computing, if you see, first it is a distributed computing. Okay, uh, then we will have the cluster computing, grid computing. Can you know what is distributed computing? Any idea? Are you final year students or third year students? Third year. Have you studied this distributed computing? So if you observe operating system or any other application, we will have the multiple tasks will be there. Okay, these tasks will be developed as software. So individual independent task, and each task will be distributed to one computer. In simple thing, if you take the web application, so in the web application, we will have the processing of the web. When the request came, it will process it. Another thing one is DNS mapping, and the third one is management of the backend data, how it is going to manage the data. So all these tasks can be distributed. So one computer will handle the requests, another computer will deliver the data. So different computers will have the different tasks. These tasks are distributed, and one computer will have the coordinator, which will distribute all these tasks to the various computers. That we will call as a distributed computing. And next we will have the mainframe computing. So these are the large scale computers. Simply we can say supercomputers. Okay, they will have huge computing power as well as sources. Then we will have the cluster computing. Can you guess what is cluster computing? Large. Oh, ah, very good. So in the LAN, cluster computing is basically focuses on the LAN, local area network. So assume that in our institute we don't have a big infrastructure such as mainframe to compute the nowadays we will have the AI. So for AI to run the deep learning applications, we require many computational resources, large computational resources. So we don't have. So what is the option we can have? So every individual system will have some capabilities. Now what we will do is, here assume that we have the 20 or 30 computers in this lab. Now if you able to connect all these in a cluster, and one computer will distribute the computational task to the each computer. Now we can have the big computer which is capable of doing the deep learning applications. So in a lab or in a local area, we could able to integrate all systems together to work on a particular task. Then we will call as a cluster computer. Then we will have the grid computing. Grid computing means in a network. Network means it can be distributed. This computer, whatever the computers that we are integrating hardware, those computers can be anywhere. So this word is derived from the power consumption. We will have the grids. So what grid will do in power supply? This word is derived from the power supply. Grid we will call as a grid. One nation, one grid. Nowadays we can see what a grid computing will do. So it will take the input from the various power generations, whether it is a solar, whether it is a thermal, or whether it is a coal energy. So it will take different inputs, and it can handle it properly, and it will integrate it, and it will supply to other end depending on the demand. So if Hyderabad is required huge amount, but some other areas, if it is going some other directions, those areas require only small amount of the energy, but Hyderabad is consuming low energy. So depending on the load, it will balances power energy, and it will distribute it. Okay, user does not know. We don't know anything. How it is, who is generating the energy, and how it is supplied, where it is converted, and all these things will be abstract. Just we are using it for various applications. That we will call as a grid computing. Similarly, I have a requirement that I have to compute the large resource intensive program. So what I will do is I will submit it task to the and online. Okay, my task will be divided into subtasks, and it will be given to the various resources computers that are integrated. Then it will be computed, and the results will be sent back. I don't know anything where it is computed, how the resources are being balanced, where the files has been sent. All these things are abstract. That is called as grid computing. Then next one is virtualization. What is virtualization? We will frequently use this word virtualization in voice. Virtualization. Can you guess? Virtualization. Sharing of resources to the multiple users such a way that he feel that he has his own computer. Okay, he feel that he has his own computer. Then we will underlying resource will be only one. Okay, but he feel that uh, because of the we are sharing computations such a way that he cannot distinguish that or any lagging, he does not feel any lagging, so that he feel that I have my own computer, so that a single computer can be shared to multiple users. Okay, each user will have its own operating system. Okay, isolated operating system, so that you can run the multiple applications, each user. Then it is called as a virtualization. We'll have single hardware. Okay, but everyone feel that I have a one powerful computer. Then we will call as a virtualization. Then after that we will have the web 2.0, which allows various protocols, distributing computing protocols, and it is enabled to develop the web services. That is called as service oriented architecture. Service oriented architecture. So in the service oriented architecture, we will have the two things. One is service provider, another one is service consumer. Okay, so this it is like that. If you want to call a function, okay, just we will call a function, and that will be executed on a computer, that will be returned it. Okay, in the similar fashion, we will call a function in a online, that in or some normal computation, that will be executed somewhere else. That resource will be allocated somewhere else, we don't know. That will go and execute, and results will be sent back it. Okay, we cannot distinguish whether it is running locally or it is running somewhere else. So those type of things will be implemented in service oriented architecture. Then utility computing. So based on the service oriented, in utility computing means I have some storing my customers' data on the online. Then I will pay something to the storage, and I will utilize the services provided or implemented through this service-oriented architecture. Then I will use it. That we will call as utility computing. Then finally we will have the cloud computing. So in the basic idea of cloud computing is, by using the virtualization, we could manage, we could able to deliver the infrastructure as service, or infrastructure as a platform, infrastructure as a platform, so that user able to access his data anywhere. He can access data from his own, from the home, from office, or from the laptop, or from the mobile. So different device able to access the data. That's why they call as a cloud. So these are the evolution. First we will have the distributed computing, then we will have the mainframe computing. So this is the evolution of the. So can you guess? One simple idea is, assume that you want to have a planning for the trip. So you are getting the, you are paying amount for the car, and you utilize it, and you will go. So the same thing will happen in case of the cloud computing. Now you are developing a application. Okay, what will happen is, you require the infrastructure. So instead of maintaining a servers, all these things, some service provider will give the all the servers infrastructure. So delivering of computing services. So one best example, that is, have you used the cloud, this Google Colab? Google Colab. So Google Colab is built on the cloud service. It is a platform as service. And so in the platform, what they are providing, they are providing the computational as well as a compiler, which will compiles the your code. It is a platform as service. It will runs on the cloud. Okay, that is one best example, simple best example. And one more popular, that red bus application is there, booking the tickets. That is also based on the cloud. So they want to develop the booking application for the booking the tickets. So instead of maintaining the costly infrastructure, networking, sometime what will happen, users will suddenly increase it. Okay, in that time he has to increase the bandwidth, he has to increase the ram, he has to increase the computational power. Okay, all these things will taken care by the cloud service provider. So they deployed their application in the Amazon cloud. So they will focus completely on their business instead of maintaining the infrastructure, hardware infrastructure. That is the basic advantages of the cloud. Okay, so what are the things that we can provide? One is computational service, computing services, and data storage, databases, networking, and software analytics. So based on the your requirement, some users will require only hardware part, so he want the computational part and he want to store the some data, so only hardware we can purchase it. Okay, some users want to the more thing, so some they will deploy their own application, but the data will be managed by the cloud service provider. Some users want uh, everything that is provided by the service provider. So that there are different things are there, we will discuss it. So first thing is cluster computing. So in the evolution we will have the cluster computing, different computers. The main aim is we don't have supercomputers, okay, but we want to make a big computer which is having the computational power. So for that we will interconnect the all computers which are available or inexpensive computers in a LAN. Okay, one computer will manage these things, and we will submit a job to that one, and it will do the computational power. So through the inexpensive computers, we are able to build the one good supercomputer in a LAN, that we will call as a cluster computer. So we already discussed this grid computing. So basic difference is grid computing to cluster computing. We know that where is the job is executing, because it is locally connected. Okay. In grid computing, it is network connected. Network means it can be distributed, that computational node can be distributed anywhere. Then utility computing. So utility computing means, so based on how much you are using, then we will pay for that only, then we will utilize it. So it is an extension of grid computing. So we can observe here how the distributed computing will be there. So first is a given application will be divided into small tasks. Okay, for each task we will develop a code. Okay, then we will distribute into the nodes, different nodes. It is a manager task server. So whatever the task it comes, based on that it will send a request. For example, if it is handling the only databases, okay, if database request is there, it will be handled here, and if it is computational intensive, it will be coming to this one. So like that, based on the task, it will be distributed. That's why they will call as a distributed computing. Then cloud computing. So on demand, scalable, elastic computing, and the resources. So mainly thing is, so users, for example, you have developed an application. Okay, now your application has been liked by the mouth or some other means, it has gone viral, means many users are been using. Finally you have estimated that only 100 users are able to use our application. Now suddenly 2000 users are requesting for your application. Now what will happen? We need to increase the resources, all demands according to the demand. Then it is, if you are able to adjust the resources based on demand, then it is called as a scalable. Okay, elastic computing, and these resources used for services metered by the charged for only resources used. This is a very important. How much you are going to use, that much you are going to pay it. And the important one, these are the terms: scalable, elastic, and elastic computing means resources related one. Scalable means it allow number of users it can has. So for example, you have designed for handling 100 users. Now if you want to handle the 1000 users, so you have to deploy the more softwares. Okay, then it is called as a scalable. Elastic means uh, so based on the demand, the bandwidth, hardware, all these things can be adjusted. So all things, these things, that is scalable and elastic, all these things can be done on dynamically based on the demand. Okay, it is like resource multiplexing. Resource multiplexing. What is resource multiplexing? Do you have any idea? So like in a area we have a one cell tower is there. Okay, we have one cell tower is there, but many mobile phones are there. Okay, can we utilize uh, cells, that is can we communicate? For example, 100 users are there in one cell tower and 100 users are there on another cell tower. Now these 100 users at a time can communicate with others 100 users, but there is only one channel is there. Bandwidth, only one channel is there. How it is possible? If it is yes or no. So what we will do is, if you remember in OS operating system, round robin. So in a given time, for example, we have the 10 milliseconds. These 10 milliseconds will be shared to 100 users. Okay. So in each slot, one user content will be inserted. So 100 milliseconds time, whatever the bandwidth that we are having. So in that bandwidth, we are going to insert the first users and then next users data. So like that 100 users information will be inserted and will be communicated with the server, that is multiplexing. So we are able to multiplex it. Resource multiplexing. What is the advantage? It will reduce the cost. Now what are the infrastructure that we require to maintain the cloud? Management. First one is, if you come networking. Okay, then we'll have the server, storage, hypervisor, that is virtualization. Then we will have the management software which manage the resources, which resources are free and which resources are being utilized, or it can adjust on demand, it can adjust the resources. And the deployment software, the user able to deploy their applications easily. That will, these are the infrastructure that is required for the cloud computing. So the most important is virtualization. To, because of this virtualization and hardware, these two things are made cloud computing is popular. What is virtualization? Virtualization. There actually 100 users are there. Assume that 100 users are there, but only one computer is there. They are able to access it such a way that they feel that they have their own computer, but internally we have only one computer is there. And this concept you can also encountered in the OS, virtual pages. Virtual pages. So we have 10 MB memory, but we want to execute the 20 MB memory, that is RAM. We have only 10 MB RAM, and we want to execute the 30 MB RAM. That the application is demanding 30 MB RAM. Now what we have to do is, we will use the hard disk. Okay, hard disk. From the hard disk we will have the a page, and it assumes that I have the 30 MB of the RAM, even though we have only 10 MB RAM. We are able to implement it. So the actually the memory physically it is 10 MB RAM, but through the help of the hard disk we could able to virtualize the things. That application feel that I have the 30 MB RAM, but actually we have the 10 MB RAM. That we will call as a virtualization. So actually one thing will be there, but for user will perceive that I have the computer. Okay, that we will call as virtualization. Here we are virtualizing the operating system, we are virtualizing the environment. So all these things. So we will have the single most powerful hardware platform will be there. Okay, this platform will be shared for different users. So we will have the virtual operating system 1 and virtual operating system 2 and virtual operating system 3. So each user who is executing his own application will feel that I have a supercomputer. So these are will be run simultaneously. So this hardware will be shared between the all the users. Virtualization. Even when you are launching Google Google what will Google platform to run your program, you can see even if you are experiencing the uh, Kaggle, if you see the Kaggle, if you run the start, it will say that I am starting the virtual machine. You can clearly see that those messages. So we will have the virtual machine. So in the virtualization, the implementation software in the cloud, we will call as a hypervisor. We will call as a hypervisor. So its main function is to run the virtual machine, and it will manage the all programs that allow, and multiple operating systems will be shared on a single hardware. You can see this hypervisor. So the hypervisor is a software program which allows the virtualization. That is, it will have the multiple operating system that run simultaneously on the single hardware, so that user feels that I can have the my own system. Why we require the virtualization? What will happen if you don't have the virtualization or hypervisor? What is the problem? Can you guess? Cost will be increased. First thing is cost will be increased because everyone required the one hardware. But when we are multiplexing the resources for each user through the virtual operating system, the cost will be decreased and maintenance will be very easy. So based on the demand, for example, if you have the 3 users, okay, we cannot assume that all users will be used simultaneously same heavy task. Some users will have browsing, some users will be executing, like that. So the resources will be used effectively. So various steps in the virtual machine creation. So basic steps that you will understand in operating system. So when you executing your program, what are the basic steps that you will encounter? The same steps will be there. First thing is, to execute any program, we require the memory. Okay, we require the memory. Okay, once after allocating the memory, we will run the virtual machine. What is the break time? Okay, within 5 minutes, we will complete it. Afternoon session, we will discuss on big data. So if you remember operating system concept, same thing. That are what are the required things to run the program. Once the program is running, we will call as a process. So what are the things required the process? First, it requires the memory. It will test. Memory means here RAM, not the disk. Okay. So it will check whether the memory is available or not. If once it is available, it will transfer the kernel. What is kernel? So essential functionalities of the operating system. Okay. What is the basic essential requirements? That is hardware management, that RAM management. Okay. Then disk management. All core part of the operating system that we'll call as a kernel. Kernel will be copied to virtual memory. Okay. Then we will have the set up the page tables. Then we will have release of the foreign mapping. That is, if any hardware that is already mapped but it is not utilized properly or it is been released, those things will be cleaned here. Then we will copy the virtual CPU to the context. That is, one hardware will be allocated. it seems that it is, but it does not have the physical, but it will be allocated like round robin. One timestamp will be given to each user, that we will call as a vCPU, virtual CPU context. Then we will launch the virtual machine. So if any already allocated hardware will be there, allocated RAM, those are not using, then we will perform the foreign mapping cleaning and memory CPU check whether all will be ready to run. Then these are the main process, virtual machine creation process. Even if you remember in Java, if you have experience Java program will be divided in two parts. First one is compilation. Then after compilation, bytecode will be generated. These bytecode will be executed on the Java virtual machine. Okay, like that, same virtual machine will be here. So what is the advantage having Java virtual machine? In C language, we don't have virtual machine. So once if you compile it, it will generate the machine level language, machine understandable code, and where the cloud. So if you observe here a network, how the network is drawn, is it look like the cloud? Network symbol. This symbol is look like the cloud. So they derived the cloud computing. And most important one is you can access the data from anywhere. You can access the data from the your home, or you can access the data from your office, or you can access the data from your tablet, mobile phone, or computer. So it will be available everywhere. So it is independent of the hardware, we can access the data or applications. That is the advantage of the cloud computing. So if you see that security, that previously sir, last two sessions, Dr. Satyababu sir has discussed the security point of view. Okay, then management. So what are the resources are available, how much it is utilized, allocating the resources, all these things will be taken care by the management module. Then infrastructure, that is hardware. Then storage, cloud runtime, and services, that is application oriented. Some services will be there. Then we'll have the application deployment. These are being accessed. So there are two parts are there. One service consumer, another one is service provider. Okay, who will maintain all infrastructure. We don't care. The service consumer does not think about this environment. He will pay the amount and he will use this environment. Like that, we will pay the amount for the car and we will use it, and we will return back it. It's rent. Okay, so the car problems, tire, petrol, and driver, all these things managed by the service provider. Okay. Shall we continue for afternoon session, or you are willing to continue?